Okay, we're going to work on the CVPM practice problem 2 algebraically. Okay, so we have two light cycles that are going at each other from a distance away. They're both driving at constant speed. They're both driving in constant directions, so CVP does indeed apply. Because both of these are moving at constant speed and constant direction. And with constant direction, so that's constant velocity. So we're all set with CVPM here. Alright, how long will they, after they begin driving, will they pass each other? Alright, so we'll have to call, we'll call one left and call one right. They're going to move toward each other. I'll have this one be the slower one, so V left is 25 meters per second. This one's the faster one. V right is 32 meters per second. And what I'll do is we'll deal with this in terms of speeds and distances rather than velocities so that we can not worry about the negatives because we know what's going on here. Actually, we should have our passing point should be closer to the left one than the right one because we know that the left one is going not as fast. So same V right and the same V left at the passing point. Okay, so overall, we can look at our two intervals. So the distance driven by the right bike is unknown, as is the distance driven by the left bike. What we do know, however, is that this total distance is 112 meters, and we know that these two take the same amount of time to do these motions, though we don't know what the time is. In fact, that's what we're solving for. Okay, so here's what CVPM tells us for the left bike. The distance that it goes is its speed times the time. For the right bike, same deal. And additionally, we know that the total distance is dr plus dl. Okay, so I have three things in here that are unknown: dl, dr, and delta t. Delta t is what I'm solving for, so I need to get rid of dl and dr. First, I'll get rid of dr by substituting from here. So dr is d minus dl. Now I can substitute for dl, and I don't have that anymore either. Okay, now I need to solve for delta t. It's in two different terms, so I need to collect all the terms of delta t on the right side. Okay, factor. And divide. Okay, I want to check my units here. As I plug in my numbers, 112 meters over, so one of them is 25 meters per second and the other is 32 meters per second. So the unit cancellation works. Meters divided by meters per second does indeed give me seconds. And if I look at the way the function depends on the different quantities, that can help me find mistakes too. So if the distance is bigger, then this right side will get bigger, which means the time is bigger. It takes longer for them to cross. If they start further away, that makes sense. If either of them goes faster, the denominator gets bigger, so this gets smaller, and they reach each other more quickly, which also makes sense. So another good way to check for mistakes or to learn new things about the variable depends that you didn't know. I mean, we happen to know those, but sometimes we won't know all of the things going on. Alright, plug in the numbers and we get 1.96 seconds.